9th standard ICSE chemistry, chapter 9, practical chemistry. Let's start with detection of gases. There are 10 gases. The first 3 are neutral gases. They don't change the color of litmus paper. We need to learn their color and odor and the tests. For oxygen, there are 2 tests. One, it relights a glowing splinter. And second, it turns alkaline pyrogallic acid brown. So this proves that the gas, the colorless gas, is indeed oxygen. Here are examples of equations which can release oxygen gas. Hydrogen gas is released in various reactions, for example, when an acid reacts with an active metal. But how will we be sure it's hydrogen? Well, it burns with a blue flame and also produces a pop sound. It's inflammable, it's explosive, hence the pop sound. Water vapor, steam. That has 2 tests. One, it turns white anhydrous copper sulfate blue, because you see when copper sulfate combines with water, the water becomes water of crystallization, CuSO4.5H2O, giving it the blue color and the crystalline form. There is another test, it turns cobalt chloride paper pink. Now the acidic gases which turn blue litmus red. Carbon dioxide will turn it light red or pink because carbonic acid is a weak acid when carbon dioxide dissolves in water. These examples are not so important, but if your teacher insists, then you will have to learn these equations as well, which are already present in previous chapters. For carbon dioxide, there is just one test. It turns lime water milky and has no effect on acidified potassium permanganate or acidified potassium dichromate solution. You can write any one of them. Just because lime water turns milky, we cannot conclude that the gas is carbon dioxide, because sulfur dioxide also turns lime water milky. But sulfur dioxide affects acidified potassium permanganate or acidified potassium dichromate. Here it changes from pink to clear colorless, and here from orange to clear green. Why clear? Because we don't see any yellow particles of sulfur, unlike H2S, which does give the same observation, but it also gives some yellow particles of sulfur. So remember, it's colorless, smell is very pungent, it's a non-supporter of combustion, it's a reducing agent. Next gas is chlorine gas. It's a greenish yellow gas or yellowish green gas, but that itself is no evidence of the gas being chlorine, because there might be some other gases like fluorine is also yellowish. The test for it is chlorine is also an acidic gas. It will turn blue litmus red. In fact, it will even bleach it. But sometimes even SO2 can bleach litmus. It's an electronegative element oxidizing agent. Its test is it turns starch iodide paper blue black with no brown residue, because NO2 gas can also turn starch iodide paper blue black, but it will give brown residue as well. Vapors of nitric acid. It has an irritating odor. Nitric acid itself is colorless, but it decomposes to give NO2 gas, and that is reddish brown. Nitric acid test is it turns Ki paper brown, and it's an oxidizing agent. Hydrogen chloride, again an irritating odor. It has one test, it gives dense white fumes when a glass rod dipped in ammonium hydroxide solution, also called aqueous ammonia or liquor ammonia. And that dense white fumes is because HCl and ammonia react to form ammonium chloride, which is a sublimatory substance. There is another test. If you pass HCl through silver nitrate solution, then it will give curdy white PPT, AgCl, which is soluble in excess of ammonia. Now hydrogen sulfide, it smells of rotten eggs. It turns moist lead acetate paper silvery black. Nitrogen dioxide, irritating odor, it's an oxidizing agent. It turns Ki paper brown, just like nitric acid turns Ki paper brown, even nitrogen dioxide does. But this has one more test, it turns acidified ferrous sulfate solution brown. Even nitric acid would give brown ring with acidified ferrous sulfate solution. Ammonia, it's the only basic gas in our syllabus, meaning it turns red litmus blue. Otherwise all these gases are acidic. They turn blue litmus red. The test for ammonia is when a glass rod is dipped in conch HCl and brought near it, it gives dense white fumes. Again, those dense white fumes are ammonium chloride, a sublimatory solid. Now, action of heat on certain compounds. We need to learn the equations and the observations. When copper carbonate is heated, it gives two products. So the observation will be black residue and CO2. Write the test. A colorless gas which turns lime water milky but has no effect on acidified potassium permanganate. Zinc carbonate. Residue, yellow when hot and white when cold. Carbon dioxide, again give the test. Washing soda. White crystals become white powder. And steam. So steam will turn cobalt chloride paper from blue to pink. Blue vitriol. When mildly heated, the blue crystals will become white powder and steam is produced. But when strongly heated, this copper sulfate, white copper sulfate, will further decompose, giving you a black residue. Yeah, we have only 5 black things in our syllabus: copper oxide, copper sulfide, lead sulfide, manganese dioxide, and carbon particles. So that is one observation. Oxygen, a colorless gas which rekindles a glowing splint. Sulfur dioxide, what is the observation? It's the test. It turns lime water milky but has no effect on acidified, it has an effect on acidified potassium dichromate. It turns it from orange to clear green. Make those changes here. Zinc nitrate. Well, initially it will just turn from crystal into a powder, but more importantly, when you heat it, it will give you a residue which is yellow when hot and white when cold. NO2, so reddish brown gas which turns KI paper brown, and oxygen, give the test. Copper nitrate, again, when strongly heated, it gives black residue, reddish brown test, and oxygen's test. 3 observations. But for lead nitrate, we have 4 observations. In fact, 5. 1, the residue is buff yellow when hot or rusty yellow when hot and yellow when cold. Reddish brown gas observation, oxygen's observation. 4th, a decrepitation sound or a crackling sound is heard. And also, this lead oxide letharge, it fuses with the test tube. Ammonium chloride. Well, a solid when heated gives you 2 gases, and when they cool down and combine with each other, it gives you back the white solid on the cooler surfaces of the equipment. This proves that it is ammonium chloride. You see, it's a sublimatory substance. And such a reversible reaction which happens because of heat is called thermal dissociation. Iodine, when you heat it, the violet solid particles become vapor, and when they come in contact with cool surfaces, you get back the violet powder, proving that it is iodine. Also, in a starch solution, a filter paper dipped in starch solution turns it blue, and the vapor also turns paper dipped in silver nitrate solution yellow, proving that it is iodine. Ammonium dichromate, well, it decomposes to give chromic oxide, which is green in color. That's one observation. Secondly, this was an orange solid which erupts like a volcano. Flashes of light are given out. That's second observation. Steam observation can also be written. There is no real test for nitrogen because it's a neutral gas. It doesn't support combustion. Now, if you have 4 objects, metal, a carbonate, let's say calcium carbonate, calcium sulfide, and a calcium sulfite, and calcium metal, or 4 powders, white powders in 4 beakers, how will you identify which one is which? Well, add dilute HCl in all 4 of them, or dilute H2SO4 in all 4 of them. Here, hydrogen is given, so do the hydrogen test. Here, carbon dioxide is given, so do the carbon dioxide test. Here, H2S test, and here, SO2 test, and that's how you can identify what type of substance it is. For example, if from a beaker you see a gas which turns moist lead acetate paper silvery black, that means that gas is hydrogen sulfide. That means that the salt is a sulfide salt. Now, the flame test. Well, the procedure is just read. You remember that in the flame test, the platinum wire has some salt. If the flame is golden yellow, it's sodium salt. Lilac flame is potassium, and brick red is calcium salt. Hard water, soft water is same as what we studied in water chapter. If it doesn't lather with soap, it is hard water because of 6 salts. If it has bicarbonates, it's temporary hard water. When you heat it, you get carbonate precipitate. You can filter it out, throw it away, and now that water will lather. But if it is because of chlorides and sulfates of calcium and magnesium, it's permanent hard water. That cannot be removed by just heating it. Whereas temporary hardness can be removed by heating it because it decomposes. How to remove permanent hardness then? Well, add washing soda, sodium carbonate. That will precipitate out the carbonates and filter it out. The water remaining is soft water. It will lather in soap. This can also be used to remove temporary hardness, by the way, which is better than boiling. Detergents are even better than soaps because detergents can lather even in hard water. No need to do anything. But we should use biodegradable detergents. Now, this whole page is read, except learn this. Sometimes detergents and fertilizers, they have a lot of phosphate. If they enter the lake, you'll have an algal bloom, because of which eutrophication will happen. All the oxygen content will be used up by the algae, and when they die, the bacteria decompose them, so no oxygen is left for the marine life, and even sunlight is blocked. That's why water pollution should be avoided.
Hi students, this is AJ sir. If you found this video useful, press the like button. Also, if you'd like to enroll for my test series or online lectures, email me or message me on Instagram. Check my description for more information.